Hey guys, welcome to my channel and today I'm recording Cambridge O Level Paper 2 October November 2021. Um, so I've already uploaded its part 1 previously and this is its part 2 video in which I'm going to solve further questions. So without any further ado, let's get started. I've already solved question number 1 and question number 2 in part 1. You can check it out in the link in the description below. Alright, let me erase this. It's okay. Alright, so okay, so it's gone crazy. Anyways, question number 3 says magnesium ribbon reacts with dilute hydrochloric acid Mg plus HCl is equals to MgCl2 plus H2. And part A says the graph shows the volume of hydrogen gas produced at 20 degrees Celsius as the reaction proceeds. The magnesium is in excess. Alright, so the experiment is repeated using lower concentration of hydrochloric acid. The volume of acid used and all other conditions are the same. Draw the line on the grid to show how the volume of hydrogen gas produced changes with the time when reaction is done at lower concentration of hydrochloric acid. So here we have a graph, and this graph basically indicates that a reaction is taking place between magnesium and HCl, and this is the volume of hydrogen gas that is being produced as per time. It's basically a rate graph or a rate of reaction graph. So here now at first there was this this concentration of hydrochloric acid, and now it has been decreased. We need to draw a new graph with the decreased with the decreased value. So decreased concentration value. So if we pick up this color, alright. So we need to make sure that first of all, hydrogen gas will always be produced from zero. That means at first there is no gas produced unless the reaction starts. So at 0 minutes, no reaction is done. So the graph will start from here, and then it will somewhat be lesser than 45 centimeter cube because the concentration is decreased. Concentration is decreased. That means lesser hydrogen will be formed. So you can put it anywhere below 40, for example. Let's consider it. Because we do not have exact concentration, we cannot tell the exact value of hydrogen gas, so it will just be an approximate graph. Also, it will be less steeper. Less steeper means that the rate of reaction will be slower. Alright, you can draw it somehow in this way. Make sure this line is straight. Alright, it shouldn't be like this. Okay guys, I've truly messed it up, but I need to tell you that this line should be straight and this should be a bend from here. Alright, so I've truly messed it up because I'm not really good at it, at drawing in such a place, alright, in such an environment. Moving on to part B1. Describe and explain using ideas about collision between particles how the rate of reaction changes when magnesium powder is used instead of magnesium ribbon. All other conditions are the same. So basically, here we need to explain in terms of collision, which is the main thing that we need to know, that is about collision between particles. Alright, so here the rate of reaction will basically increase because more particles are exposed, so there will be greater successful collisions. And in this way, you can frame an answer, and all the conditions are same, which is given over here. So we need to know that the only focus that we have over here is the magnesium powder is used instead of magnesium ribbon. Alright, magnesium powder increases the surface area since it's in powdered form, it's more simpler form. Alright, so that is how you're supposed to answer this question. Moving on to part 2. Describe and explain using ideas about collision between particles how the rate of reaction changes when the temperature of the reaction mixture is decreased. All the other conditions are same. So basically, rate of reaction will also decrease because temperature is decreased, and temperatures have decreased. That means there will be less kinetic energy. So the particles will move slowly. Alright, it will be slower than before. Alright, and fewer particles will reach activation energy. Hence, the reaction will get really slow. In that specific time, fewer particles will reach to their activation, will be able to attain their activation energy. Moving on to part 3, calculate the maximum volume in dm cube of hydrogen formed when 1.68 grams of magnesium reacts with excess dilute hydrochloric acid at room temperature and pressure. Give your answer to 3 significant figures. So here we have 1.68 grams of magnesium, all right, and which is being reacted with dilute excess diluted chloric acid. We're not going to really consider it. So we need to find the volume of hydrogen. That's our question basically. So here is magnesium with us. First of all, we are going to find the number of moles. Always remember, moles is a topic that you should have really quite a grip on. Alright, so here we have 1.68. Let me use a better color. Alright, so this is 1.68 grams. To find moles, we are going to divide mass with the AR of it, with the AR of magnesium, and the AR of magnesium is 24. I already remember it. You can check out the periodic table and you'll find it to be 24 of magnesium. And then the moles that we'll find over here will be 0.07 moles if we calculate. And then moving on 0.07, we have found the moles. Now we have to find the moles of hydrogen. Alright, if we go above and see over here, we have magnesium and hydrogen in the same ratio, that is 1:1. That means hydrogen also has the same number of moles. Now to find the volume in dm3, we are supposed to multiply it by 24. 24 is a very standard value for room temperature, volume at room temperature. So 0.07 multiplied by 24, so multiply this value by 24 and you will get the answer that will be around 1.68 dm cubes. Alright, so pretty simple question. Moving on to part D, magnesium is a good reducing agent. Describe the test for reducing agent. So reducing agent test is going to be, we're going to add potassium magnate 7, 5, potassium magnate 7, we write in this way, 5, 1, 1, potassium magnate and then 7 in a bracket. So do not write 7 in numbers. Alright, so potassium magnate is what you're going to add, and then the observation is going to be, it will turn from purple to colorless. In this way we can identify that it is a reducing agent. So this is it for this question. Moving on towards the next question. Question number 4 says alkanes are a homologous series of hydrocarbons. Alright, and the boiling point, melting point, and density of alkanes increase as the number of carbon atom increases. So we are already aware of this property, and this property is also mentioned in the question. Moving on to part A1, give one other physical property of alkane which increases as the number of carbon atoms increases. As the number of carbon atom increases, we already know that the boiling point, melting point, and density of alkane increases, so we are not supposed to repeat the same things. However, you need to write something different. And if we talk about, there can be so many things, and one of them is viscosity. Viscosity increases. I think, yeah, viscosity is the only thing that's left. If we increase the number of carbon atoms, it's going to be more viscous, more thick. Moving on to part 2, give 2 other characteristics of a homologous series. So homologous series have similar chemical properties. Alright, they have the same general formula. They also have the same functional group. There's so many other things that you can write related to homologous series, since they share the same kind of property, the same kind of physical. They basically share a lot of things together. Physical properties are different because carbon chain atom increases as soon as per the number of carbons over there, the chain increases. So physical properties are a bit different, since we already know that boiling point, melting point, etc., these all change. However, chemical properties remain same. So there are so many properties over here we can mention, so many things. Moving on to part B, 2 typical reaction of alkanes are combustion and cracking. State the name of another typical chemical reaction of alkanes and the reactant needed to react with alkanes. Alright, so here if we talk about it, so the type of reaction can be substitution reaction, and the reactant over here we can put is chlorine. Alright, for substitution reaction. Moving on to part C, alkanes are produced by cracking of alkanes. State two conditions needed for cracking of alkanes. So for cracking of alkane, we mainly require a catalyst and we require very high temperature. Alright, so you can write these two properties. Moving on to part 2, tridecane C13H28 can be cracked to produce an alkene with 4 carbon atoms and one other hydrocarbon only. Construct an equation for this reaction. So we have C13H28 which we need to crack in such a way that it will produce one alkene with 4 carbon atoms and one hydrocarbon only. So alright, so this is how you're going to make the equation. We already have one alkene over here, that is C4H8 is the alkene and C9H20 is the alkane. Since it's specific that we need to have an alkene with 4 carbon atoms, so this is how it's going to be cracked. You can also form different equations. You can either form CH4 for instance as the other element, and we can also have it with a ratio of 3, C4H8 with a ratio of 3. You can do anything, you can do variations in it, it's up to you. But I think this is the most simplest equation. What I think so it is. Moving on to part D, a hydrocarbon contains 88.9% carbon by mass. Calculate the empirical formula for this compound. So a hydrocarbon is, and it contains 8.9% carbon by mass. Okay. Okay, so I just repeated the same thing anyways. So 88.9% carbon by mass. Calculate the empirical formula. Here I've already solved it. Why? So that to avoid the hassle. But there are a few things that I haven't done. I haven't completed it. So here we have the color. Okay. So 88.9% carbon by mass. Here we have 88.9. This is carbon. And since it's a hydrocarbon, so it will of course have hydrogen too. How did I find it to be 11.1? Because we have the total percent means 100%. Alright, so 88.9 minus 100 minus 88.9 will give us 11.1. Then we are going to divide it with the AR, the atom, the mass of its atom, that is 12 for carbon and 1 for hydrogen. Then we are going to get two answers divided with the smallest value. The smallest value here is 7.4. 7.4 divided by 7.4 and then 11.1 divided by 7.4. I hope it's understood till here. Now we have it in the form of C and H. However, we never write decimals. Alright, it's not a very good idea to be writing decimals with hydrogen because we cannot it's not practical, because we can have one carbon atom, we can have two carbon atoms, but we cannot have 1.5 carbon atom. Alright, so basically we need to have complete atoms. Atoms cannot be divided to have its same properties. So if you see carbon, we have 1 over here and hydrogen is 1.5. 1.5 is the middle value. That means it's neither close to 1 nor close to 2. So we can multiply it with 2 to get a more better form. So we'll have the empirical formula. The smallest formula for this will be C2, and 1.5 multiplied by 2 is 3. So C2H3 is the answer. So this is it for this question. I hope you found it helpful. In case you have any question, make sure to drop it in the comment section down below. I'm going to be posting more videos of October and November 2021, and since exams are really near, and hence I'm going to be uploading videos, more than one video every day. So make sure you subscribe and ring the bell icon so you are updated with every video I upload. And yeah, that's it. Thank you so much for watching and best of luck for your exams.